All right, guys, last video of the year. Okay, sequences. So for sequences, there's two types. There's arithmetic. And when we say arithmetic, what this means is essentially we're creating a linear function. So we're adding or subtracting to get from one point to the next. So to figure out what the change is, you're going to take the second term, subtract the first. So if you think about like a table, like an XY table, right? If we're doing points 1, 2, 3, 4, and so on and so forth, I'm going to take the y value from 2, 4, and I'm going to subtract away the first one. So 4 minus 2 gives me a change of 2. If the next one's 6, 6 minus 4 gives me a change of 2. So you always take the second term minus the first, third minus the second. If that term is the same and it continues to be the same, it's an arithmetic sequence. The explicit formula follows this lovely formula, which is a sub n, some term in line like y, is equal to the first term, okay, which essentially you can think about it as this is your y-intercept, okay, that's your b, and then the n minus 1 times d. So d is essentially your slope, right? What are you adding to get from one point to the next? And then you're doing n minus 1. So if you're at term 1, it's term 0, okay? Whatever that is when you plug it in. So a1 plus parentheses n minus 1 times d. Let me check something real quick. All right, this is the Regent's formula sheet. This is the reference sheet. And you can see right here, the arithmetic sequence and the geometric sequence are given to you. So you don't need to memorize them. They're right on your sheet, okay? So Pythagorean theorem, quadratic formula, arithmetic sequence, geometric sequence. And then they have some area formulas over here. Pretty much won't be using this stuff for our purposes. There is an exponential growth and decay, but we can do it without that. And then high school math reference sheet in terms of the conversions, those conversion factors are up here. All right, back to it. So the starting point is essentially what's the first term. So if an equals d and then a sub 0, so it's d times n plus whatever a0 is, the first term. So if you went, think about your chart, if I went back to the x term that was 0, okay, and I went back 2, this would be at 0. So my x and y value would be 0, that means b is 0, so mx plus b, so a0, and then 2 times n. So if this is the formula I'm starting with, the starting point is going to be that formula. The recursive formula is, give me any formula you want. If I want to do a2, it's a, 2 minus 1, or a1, and then plus d, whatever that is. So in general, the formula we're going to use, instead of putting a2 here, is we're going to use an, okay? So an, give me some term. I'm going to take the term before it, a sub n minus 1, and I'm going to add d to it. Geometric. A geometric series is essentially just an exponential series, okay? To get from one term to the next, you are going to multiply or divide. So if I take and do division, second divided by the first, third divided by the second, okay? And if you think about it, if I do stuff like times 3, so if I do this as 1, 1, 2, 3, 3, 9, 4, 27. You can see we're always multiplying by 3 to get from one term to the next. So this would be a geometric sequence for those points. So if I did 27 over 9, I get 3, 9 over 3, I get 3, 3 over 1, I get 3. The explicit formula is right here. It's a sub n equals a1 times r to the n minus 1. Okay, remember we talked about that right here. Okay, you guys can see right there. All right. The starting point is to work backwards 1. So I just decrease 1 to 0 and n minus 1 to n. All right. And the recursive formula, if I want to do a sub, let's say 7, I just take the term before it, which is a6, and multiply it times r. So in general, it's an equals the term before it, an minus 1 times r. All right. When we talk about a sub n, that's what this intro part says. Okay, it's the sum, it's the nth term in the sequence. So in general, it just represents like a y, okay? A sub n minus 1 is the term right before that term, okay? So if if we're talking about the 12th term, a sub n minus 1 would be the 11th term. All right, this is for the recursive formula. A sub 1 is always the first term in the sequence. All right, n is treated like a variable, like x. I'm going to pause while we hear the siren. All right, it's treated like a variable, like an x formula for x. That's the term number. So A2 would be the second term in the sequence. D is the common difference. All right, we're just going to subtract 2 minus 1, so it's what you're adding to get from the next to the one term to the next in an arithmetic sequence. Okay, and R is the common ratio in geometric sequence, what you're multiplying by. To figure out what that is, you're just going to do some division here. Okay, A2 minus 1, A3 minus A2. All right, so in a sequence, the first term is 4 and the common difference. So as soon as I see common difference, it tells me it's arithmetic. Okay, it's 3. The fifth term of the sequence is what? So I know the first term is 4. The second term is 3 more because the common difference is 3. So it's just 4 plus 3, okay, which is 7. The third term would be plus 3 more. So 7 plus 3 is 10. Guess see how this works? Fourth one, 10 plus 3 is 13. And the fifth one would be 13 plus 3, which is 16. So that's how I know the answer to that guy. All right. State whether the sequence displays exponential behavior. Describe how you got your decision. So if we take, for example, if this is A1, A2, A3, and A4 as 27, 9, 3, and 1 respectively there, we would know that if we did A4 over A3, and that's equal to A3 over A2, and so on and so forth, if that's the same, that means we're multiplying to get from one to the next. So 27 over 9 is 3, right? 9 over 3 is equal to 3. So does this display exponential behavior? We would say yes. If it says determine whether it does, make sure you say yes or no. All right. So we're going to say yes, it displays exponential behavior. All right. Since we are multiplying by 3 or by the same constant amount to get from one term to the next. All right, and that'll be enough. All right, get the phone. Hold on, guys. All right, so going on to the next page here, the sequence of blocks is shown below. The sequence can be defined by the recursive function a1 equals, and then it's an equals a sub n minus 1 plus n. Assuming the pattern continues, how many blocks will it be when there's 7? So you can see, like in the first one, there's 1, right? The next one has 3. Then it's the second sequence has 3 because that's the last one, plus 3 because it says the third sequence, so 6. And then the next one has 6 plus 4 because it's the fourth sequence, which is 10. Okay, so if we kept going, and we can kind of make a chart for ourselves here if you want to, in the XY table here of doom. All right, so 1 is 3, 2 is the previous term 3 plus 2, which is 5. Wait. Oh, it's the last one. 2, time out. 1 is 1. There we go. 2 is 2 plus 1, which is 3. Okay, 3 is 3 plus 3. So I'm just adding these two together to get 6. 4 is 4 plus 6 is 10. 5 is 5 plus 10, which is 15. 6 is 6 plus 15, which is 21. And then 7 is 7 plus 21, which is 28. So if you see the pattern, you can use it and get the answer that way. All right, that's just what we're looking for. For recursive, you always have to plug in the one before it. So you have to do the work up to that row. All right. Assuming the pattern continues, what formula is determined? So we know we want to look at the formula here, the nth term, and we want to figure out if we're adding or subtracting the shaded squares. So like we can count the shaded squares in term number 1, 2, 4, 6, 8, and 4 is 12. Right? 3, 6, 9, 12, plus another 4 is 16. 4, 4, 4, 4 is 12. Well, that's 16. So it's 20. You can see these are going up by 4. Okay? So plus 4 every time. So if I'm looking at this and I said, what would be in the very box 0. If this is term 1, what would be in box 0, right? Is essentially looking for. Or if we did a sub n, okay, is equal to a sub 1 plus n minus 1 times d, right? We can plug in here now. A sub n is the first term, which is 12, plus n minus 1 times d, which is 4. And we could just solve, right? So if I distributed the 4 through, okay, I would get, let me see if we can move this up so we can get more room here. Nope, you go away. Yeah, up, all right. So if we distribute, we're gonna get a sub n is equal to 12 plus 4n minus 4. And then the 12 and the 4 are like terms. So we're going to get 4n plus 8. All right. You can also just plug in. If I plug in 2 for this, right, I should be able to get 16. Whereas I plug in 2 for this guy, 4 times 2 for the first one, right, plus 12, I'm going to get 20. And you can kind of play along that way. Your other option is that you can take your calculator, okay, and you can do a linear regression. Okay, new document, don't want to save. List in spreadsheets. I title this X and Y. 1, 2, 3. Right, we got 12, 16, 20. And then I go to menu, statistics, stat calculations, linear regression mx plus b, and I go choose my variables, so X and Y. Get OK, and there's we go. So 4x plus 8. You can get it that way too. Okay. All right. Which function defines the sequence? F of 6 is negative 26. So first of all, how are we getting from one term to the next? So we're going from 10 to negative 6. Negative 6 to negative 10 is down 4. We're going down 4 again. So we know this is arithmetic. So it's going to follow that same sequence, right? A1 plus n minus 1 times d. We're going to plug in and then simplify. So the first term, it says, is 26. So we want to make sure, like the first term, so an, the first term is negative 6, okay, plus n minus 1. So n minus 1, and then d is minus 4. And so if we distribute, we're going to get a sub n is equal to negative 6 plus, or in this case minus, because it's negative 4 times n. So then minus 4n and then plus 4. And if we combine like terms, we're going to get negative 6. Sorry, not negative 6. Negative 4 goes first. And then we're going to combine the negative 6 and the 4 here to get minus 2. All right, so it's negative 4n minus 2, and there's choice 1. All right, the third term of the negative sequence is 10. The fifth term is 26. First term a1 is in the sequence for the nth term, which is the equation for the nth term of the sequence. So if you know it's arithmetic, you can kind of go to third term is 10, okay, and then the fifth term 4, 5 is 26. So I have a change of 16, right, to get from here to here, and I have 2 jumps I have to make that are equal. So if I do 16 divided by 2 is 8, then I know I'm basically going down 8. So this would be 18. If I went down 8 more, I'd be at 2. And if I went down 8 more, I'd be at negative 6. So I can kind of use this pattern to help me out. All right, so same thing we did before. an equals a1 plus n minus 1 times d. Okay, there's a 1 there, guys. Very slowly written. All right, so an equals, first term, negative 6 plus n minus 1 times d. Let's do this. There's my wall. All right, and d here is 8, okay? As we counted, there's a change of 8 to go from plus 8, plus 8, plus 8. So if I distribute, I get an equals negative 6 plus 8n minus 8. And then the -8 and the -6 is going to give me -14. And there's my answer. All right. Which expression divides the nth term? So same thing. It's what are we doing to get from there to there, to there, to there, to there, to there? We're basically adding, okay? And we are adding 15. So that's going to be D. So same thing. A sub n equals A1 plus n minus 1 times D. Okay, A1 is -27 plus n minus 1 times 15. We distribute, okay? -27 plus 15n minus 15. Combine our like terms here, okay? Or do we even need to do that, right? I can stop actually right here, all right? And you can see the 15, this is written with the 15 in front. So it'd be -7 plus 15 times n minus 1. Which function could be used to represent the sequence? And here, now we're jumping up. So 8 to 20 is 14. And then all of a sudden we're going up 20. So this is not going to work anymore. So instead, what we need to do is take 20 divided by 8. And is that the same as 50 divided by 20? Is that the same as 125 over 50? And it is. And if we divide those numbers, okay, okay, so 20 over 8, 20 over 8, ignore that, okay, too much undos, 20 over 8, all right, 50 over 20, okay, so we're getting the same thing, right, 125 over 50, we're getting the same thing, 5 over 2. So this is equal to 2.5 or 5 over 2, all right, which is really just 2.5. So we can think of that as 2.5. That's the R value. All right, so the sequence is A1 equals AN equals A1 times R to the n minus 1. Okay, that's the sequence, guys. So when we're doing this, if you want to double check, there we go. Okay, AN right here, right there, right here, guys, right? That's where we're looking right there. Okay. So we're plugging in. So AN equals the first term. First term in line is 8. Okay. 8. Yeah. Get out of the way, complete. Where'd you come from? I don't know. All right. Times, and then it's R, which is 0.25 or 5 over 2 to the n minus 1. This is a little weird. Now, there's another option, which is that we do a regressive regression here, a recursive function. So the recursive function would equal an would equal a sub n minus 1. And that's what's going on here because I have these n minus 1s, where this is in terms of n. And then what it is, it's a to the n minus 1 essentially times r. Okay, so we know r is 2.5, and if we multiply that times a minus 1, we're going to get this answer right there. So this is the explicit formula. This is the recursive. So if this one is not matching anything, like what the what, try the recursive formula. All right, and on the last page here, I'm going to pause it as it loads here. We got a little recursive stuff. Write the first 5 terms of the recursive sequence defined below. So all we're doing is, when this says a minus 1, it really means the term before, okay? So as I do a2 equals 2, this really means a sub 2 minus 1 or a1 squared minus 1. That's what that literally means, okay? So as we're doing this, keep that in mind. We're going to move this over here to the left so I have some room to work. I want to keep that there so you guys understand what we mean. All right, come on. Light it up. All right. So what this equals then is instead of A1, I'm going to write 0. So A sub 2 equals 2 times 0 squared minus 1, which is, this is 0, so it's just negative 1. A3 equals 2 times A2 squared minus 1. Okay, so this equals, right? I guess we don't need this. Okay, this equals 2 times negative 1 squared minus 1. So negative 1 squared is just 1, so this is really 2 times 1 minus 1, and that's 1. A sub 4 is really 2 times A sub 3, okay, squared minus 1. So that's 2 times 1 squared minus 1, okay? So 2 times 1 squared is 1, okay? 2 times 1 minus 1. And this is equal to 1 again. And then A5, all right, is 2 times A sub 4 squared minus 1. And then this is 2 times 1 squared minus 1, which is just 2 minus 1 again, which is 1. All right? And that's the first 5 terms of the sequence, right? The first term is 0. So the first 5 terms of the sequence are 0, then negative 1, and then 1, 1, 1. And we're stuck in this endless loop of 1s here. Okay? All right, same thing for the next one. If the pattern below continues, which equation is recursive formula that represents the squares of the sequence? Now, the recursive formula is always going to be something with a sub n minus 1. That's how I know it's recursive. So these two are out, okay? Those are like an explicit formula for the equation. So I know with design 1 that there's 3 terms, all right? With design 2, we've gone up to 5 terms. With design 3, we've gone up to 2, 4, 6, right? 7 terms. So it basically looks like I'm taking the term before it and I'm consistently adding 2 to get the next number, right? Plus 2, so plus 2 is going to equal 9. So now I know that the first term is 3. My recursive is a sub n equals a sub n minus 1 plus d. And d is 2, so a sub n is equal to a sub n minus 1. That's right there. I'm just running right again. It's this guy. The first term is 3, and then I'm doing a sub n minus 2 plus 1. I don't need anything else. So this is my formula. That's the first term. We're choosing choice 3. 574. Recursively, this function is defined as, and we can see we go from 3 to 7, that's plus 4, and then we're jumping to plus 8, so there's a problem there. So if I do 31 over 15, okay, and this is an exact, this is also not a, let's try it. 31 over 15, is this the same as 15 over 7, and is that the same as 7 over 3? That's our first question, okay? We want to know, is this geometric as well? Remember, some sequences may not be arithmetic or geometric. So 31 over 15, right? And then 15 over 7, they're not, guys, they're not the same thing here, okay? Instead of hitting enter, we can hit control enter, and that'll give us the decimal. So you can see, okay, those oh, look, wait a minute, did I hit the same thing twice? I think I did. 15 over 7. Control enter. Right. See, they're not equal. So this is not recursive. This is not arithmetic or geometric. It has its own rule. So we have to figure out using this guy whether or not the sequence works. So I would go through the list and try 2. Okay. So it says f of n plus 1. N plus 1 essentially means if I'm doing f of 1, then I'm going to be talking about f of 2, okay, equals, right, 3 times f of 1 minus 2, okay? So when I plug 2 in here, I'm actually going to use the first term over there. If I plug 3 in here, I'm using term 2 in here, okay? And we can kind of go through the list and see what's going to work and which isn't going to work. So if I do 3, okay, 2 times 3 is 6 plus 1 is 7. That works. 3 times 3 is 9 minus 2 is 7. That works. Okay. These two don't make sense because it says f of n, and we don't even know what f of n is. I guess it would be, if you plug f of 1, it would be 3. So 2 cubed plus 3, that doesn't work, right? And for 1, f of 2 would be f of 1, which is 3. So 2 cubed minus 1, that would work. But then we would do 7 to the third minus, that doesn't work. So these are out. So these are our options. So if I plug in, okay, 7, if I do f of 3, that's going to be 2 times f of 2, right? And then plus 1. Well, f of 2 is 7, so 2 times 7 plus 1, that is 15. If we try the other one, okay, f of 3, now we're going to try the bottom one here. So let me change this. This makes sense. All right. So if we're going to do f of 3 down here, f of 3, that means we're going to do 3 times f of 2 minus 1. So 3 times 7, sorry, minus 2. This is 21 minus 2, and this is 19, but it's supposed to be 15. So we know that sequence out. So we're left with choice 3. So we're doing a little guess and check here to see if this works. Which recursively defined function has a first term equal to 10 and a common difference of 4? All right. So first term of 10 means f of 1 has to be 10. So these two are out. All right. And then if you plug in, if we do f of 2, this says if I do f of 2, that I'm going to take f of 1 and add 4 to it. Okay. So we're going to basically do 10 plus 4, which is going to be 14. This one says I'm going to do 4 times that. So f of 2, right, is going to be 4 times 10, which is going to be 40. And that's time. So common difference also means I need to be adding. That's how I know I'm going to be doing choice 1. Pattern of blocks shown below, which, if the pattern continues, which formula can be used to determine the number of blocks? So we just have to go through our choices to see if they work. All right. Also, I know that choice 3 is in all of them. So if 3 doesn't work, we're going to just choose 2 or choice 1. So that's another option. Thank you, Kennedy. All right. So for term 1, there's 2 of these. For term 2, you can see there's 1, 2, 3, 4, 5, 6 of them. For term 3, there's 10 of them. For term 4, there's 3 of the 4, and then that's 12. And then 2 more is 14. So we can see by doing this, we're basically adding 4 to get from one term to the next. So this is an arithmetic sequence, okay? So I know that my formula that I could use is an equals a sub 1 plus n minus 1 times d. All right, so an equals the first term, which is 2, plus n minus 1 times d, which is 4. And then we'll just distribute. So 2 plus 4n minus 4 is 4n combined like terms. The 2 and the negative 4 gives me minus 2. So this works. So that means this is out. Okay? That means this doesn't work. Because if this one does, this one doesn't. So that means this is out. So the question is, does this sequence work? If the recursive, is 2 the first term? Yes. If I take every term and take the term before it and add 4, will I get my sequence? Yes. So we want to choose terms 2 and 3. And if you're not sure, just do it to it. So if I do A2, does that equal A1 or 2 plus 4? Does that equal 6? Yes, it does. A3, does that equal 6 plus 4? Does that give me 10? Yes, it does. So that's how you can check it. All right, that's it for today, guys. Thank you for your hard work this year in this quarter. Don't give up yet. We still got till next week. Remember, your homework tonight is do the part 1 of the exam. If you forget, I'll send a link out to a copy of the exam. I'll actually post it. Just do it on a separate sheet of paper and bring it in. So check remind if you forgot it. See you later, guys.